Well, today is a special day here on Let's Code Physics because we have reached 5,000 subscribers. Thank you all so much for your interest and continuing support of this channel. And I wanted to celebrate by taking a look at an interesting sequence that includes the number 5,000. There it is right there, kind of toward the end of this truncated list of this really interesting set. This from the Online Encyclopedia of Integer Sequences is sequence A192476. It is, and you have to kind of get past the wording here because it is really cool, monotonic ordering of set S generated by these rules. If x and y are in S, then x squared plus y squared is in S, and you start with 1 in S. So it kind of helps to read this backwards, right? So start off with a set S where you have the number 1 in S. So we're starting with 1. Okay. Then you say, if there are two numbers x and y that are in S, right? So in this case, that would be 1 and 1. Then you get to add x squared plus y squared to S as well. So for example, if you have 1 in S, then 1 squared plus 1 squared should be in S. 1 squared plus 1 squared is 2, so there's 2. Then you go back over again. You say, okay, 1 and 2 are in S, so 1 squared plus 2 squared should be in S, and that's the number 5. And this is where it gets interesting because you start to do different combinations. So like you should have 5 squared plus 1 squared should be in S as well. So that means 5 squared is 25 plus 1 squared, so 26 should be in S. So there we jump to 26. But you should also have 2 squared plus 2 squared. That gives you 8. But you should also have 5 squared plus 5 squared. That'll give you 50. And you notice we skipped over this 29. Well, that's because you've got to, how do you get 29? You've got to take maybe that 16, no, excuse me, yeah. That's going to be 5 squared plus 2 squared is going to give you 29. So it's like you got to keep going back and forth with these different combinations to get out another number. And so it's entirely possible that you jump ahead in the sequence and then have to jump back to get one. And so this is simply ordering them in increasing order of so this is ordering them in increasing size, and that's what this part monotonic ordering means. It's not the order you would arrive at them at, it's the order they would appear if you put them in numerical order. And there, right there, you get 5,000. And this is a really interesting sequence, I think. I've got it set up over here in GlowScript on Trinket. I went ahead and started out with set equals 1, 2. I suppose you could just start with a set of 1 and you would get the same results. We'll try that at the end of the video just to confirm that it works. But basically, what we're doing is we're setting up a loop here, and I suppose I can get rid of all of my rate and print statements here. So we've got here is a loop that says while the maximum size of the set, maximum element of the set is less than 129. You say, Brian, I thought we were going to 5,000 for this. Well, this is how many you need in order to get 5,000 in the set. Because remember, you keep adding more onto the set, kind of like layers of an onion. And so this is the maximum number you need for the next layer to include 5,000. So what we do, we're going to look for numbers that we need to add to this set. And so the way we're going to generate the numbers we need to add is we loop over all of the x and y in the set. So all the numbers in the set, and then all the numbers in the set again. So we're keeping track of x and y separately, right? That's how it was phrased. Because then x squared plus y squared should be included in this set. And so here we've got z being calculated as x squared plus y squared, and we only need to add it to the set once. And so we're checking here for if z is already added or if it's already slated to be added, because it's entirely possible we come across the same thing twice. If that's the case, we don't need to do anything, so I've just got a little dummy line here just so that Python has something to do. And then here we say if it's not already in the set, then we add it to the list of things that need to be added. Now, you notice I'm keeping two different lists here. I'm keeping the set here and the to add, because if I keep adding stuff to the set, then that makes these loops continue to go on forever and ever, and you won't ever get the program to finish. And so then here we just add all of that stuff we're supposed to add. And here I'm just keeping track of the number of iterations just for the sake of completeness to see, how many iterations it takes to get through. Then here's where we do the monotonic ordering. So this is just putting them in order. And then we need to be able to graph these. I want to be able to graph these. So here on the graph, we've got the elements of the set and then where they are in the sequence. So everything is evenly spaced along the x-axis, and the y-axis kind of shows us, where the jumps are in the values in the set. And so we've set up a graph here to do that. I've also printed the elements of this sequence. You can see we go way past 5,000. So here's 5,000, and here we get all the way up to 32,768 is this top value up here, which is a lot. All right, that is well past 5,000. And this sequence makes a really interesting graph because, it quickly blows up out of proportion. Well, not out of proportion. It quickly blows up here to where all of these first elements appear to be, kind of flat. We get a little jump there, we get a jump there, and then we start to get these bigger jumps, right? So right here, around 50, what is that? Right around element 54, so 12,400 something. It makes a big jump, and then we have kind of a nice little level path, and we get a jump, and then we get a really big jump over here. So for those, you're adding smaller numbers together. So you're adding, maybe you're adding, something like 68 squared plus 1 squared. Well, you're already at an order of magnitude of that over here, and so it's not jumping up by that much. You've already got a number that's kind of close there. So like you've got everything around the 5,000s in here, which is our special number for the day. But then you've got this jump from 5465 to 6725. So that's this big jump right in here, and then things kind of hang out around there a little bit, and then you get another big jump, and so you get these gaps that it's never going to go back and fill because you've already got all of the numbers that are going to go in that space, right? You've kind of already surpassed that range there. And actually, one way you can see these layers happening is if you switch this from 129 to 128 and click run. Then there's a much shorter set, right? We're only going from 1 to 128 now, and we get an idea of what the gaps are there. But as soon as you change this to 129, then suddenly you get things going up to 32,000 or just above 32,000. But what's interesting about these gaps is if you put the vertical axis on a log scale, so you're showing powers of 10, then suddenly those gaps up here become much smaller, and the gap between, 128 and 677 is huge, right? And that was our cutoff before, right? So if we make this go to a 128, we'll click on run, right? That, it doesn't exaggerate it too much there, but as soon as we let this thing go past 128, then we've got this huge gap right there on a log scale, and then the gaps up here don't appear so big on a log scale. So anyway, I was very happy to find this sequence and see that the number 5,000 is a member of it, so that we can have a proper mathematical celebration of a mathematically significant number of subscribers. As always, thank you all so much for watching. I will see you next time. Bye-bye.